Or we have models like GPT-4o that now can process text, image, audio, video, and output text, or even image, audio, and video inside the same model. It means that the main source of intelligence, for example, in applications like GPT-4 or the models, they would lose a lot of information during these translations. These new Omni models, like GPT-4o and Llama Vision and all, they can do this end-to-end translation answering, actually, across text, vision, and audio directly. All of the information is processed in the same neural network. And it makes a lot of sense, because if I say something in one intonation, like, what? Or if I yell, what? Or if I say, what? The string representation of those three things would be the same. But the possible meaning conveyed in those three different expressions would be different, depending on how I say it, okay? There are even languages like Mandarin, I guess, and some others that depending on how you sing the vowels and all, the words get a totally different meaning. So getting this correctly in a string, in an actual representation of that meaning of that word is tricky. When you have the same model to process all of this at once, instead of going from audio to text and then text to text and then text to audio back, you have a lot more of intelligence, and you have much less latency. You can even like speak with the AI like it was a human. Before that, it would take a few seconds, like 5.4 seconds to answer. Something like this. Hey, good morning. Good morning, how are you doing? It doesn't seem natural, right? So with GPT-4o and those recent models, you can have that under 200, 300 milliseconds, which is much more acceptable for our conversation. So this multimodality is great on the user part, like the user interacts with it, of course. But we are going to see that it's even more than that. We're going to see that when the AIs have more information about something, this creates some sort of world scope for the AI, and even increases, giving like image information from an AI about objects, even increase the text-to-text answer for some sort, as if the AI would get new perspective on how information can be correlated. And maybe this is, we don't know, but maybe this is the solution for the problem that we have right now on data, like synthetic data and all that people are using. Have you seen that, those news? Like OpenAI run out of data in the world, public data, so they are creating new synthetic data that's not helping so much. So this kind of research may solve this problem, or not, we don't know. Bringing the context here. And we're going to build a multimodal chat application following this tutorial. A chatbot that can receive files, that can receive image as input, for example, to generate text or even an image output in the other side. So maybe this is going to help on your projects here. Don't know here who is doing image generation or needs image output, but if your project needs that, it's going to be a great addition, okay? Who's going to need image or audio processing here? Raise your hand. The Culinary, the ShopMe, Arc Invest, just text to text? You are? Good, one. Who else? Are you going to use text to text only in your project? Or are you looking to implement audio to text or text to audio or text to image, image to image? You too? Good. Only two groups? Audio to text, that's good too. Image to text, good. We're doing image to text right now. So this is going to enhance your capabilities with AI, and it's also going to give some more context on coding things here using this SDK. Okay, we're going to do this exercise with the SDK using this multimodal chatbot example with AI SDK and all. But inside the the docs, you're going to see many other capabilities. So this is just one example, okay? For example, streaming information from LLMs. So instead of having a blocking UI, you have this streaming UI. We have that in the SDK. If you want to call tools, this is going to be super important when doing agents later. We have it here in the SDK too. Working around with prompts, different prompt engineering, streaming text, streaming objects, using different providers. There are a lot more functionalities, features inside this SDK. Okay, but I'm going to show one today just to introduce the SDK for you that can be helpful for you to do your project. Okay, and we're going to do this exercise for half an hour or so together, coding together, until at the end we have application that we can use an image as a prompt to generate a text response, and it's going to combine the image uploaded and the text to give some answer. I can take a picture of an animal and ask, is this animal dangerous or not? Okay, instead of trying to describe. I have an animal that is soaring way high and it's furry, it's big, it's brown, and is running towards me. I wanted to know it, you're dead. So it's better to take a picture of the bear and then you ask, is this dangerous, should I run or not? Okay. You're Canadian, you know what I'm speaking, right? So let's do this exercise. Similar to what we did yesterday, we can even use the same folder, different repository, of course, the same folder. I have it here in my desktop, my project here. I have my next app, and I'm going to create this multimodal chatbot. Okay. Before we begin, who completed the landing page for your project already? 1, 2, 3, 4. Did you? Okay, good. 5 out of 1, 2, 3, 4, 5, 6, 7, 8. 5 out of 9. Okay. Anyone struggling with that? Using the zero cursor? No. Well, anything, let me know, okay? So this is going to be another exercise for coding together. Might help you with the things from yesterday too. Okay, coding is going well. Okay, good. And if you already have your landing page, maybe this can be your first feature, your first test feature, a mock feature that you want to put inside your app, like a login page and something like that, and this chatbot with image. Okay, maybe it's not going to help your final project, but can be an exercise. So let's do this. I'm going to open a terminal window here. It doesn't need Python yet. If you have just Node from yesterday, it might work. Okay. And I'm going to run this first command to download this script, create next app at the version latest. And then I'm going to create a project with this name. The name doesn't matter at all. Okay, you can pick any name. This is just the name of this exercise. And then you're going to pick all the default options just like yesterday. You hit enter, 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 and that goes. Yes. Okay. I had some people with problems at this step yesterday. Make sure that you have this inside a clean folder, that you know where this is, that you know how to run the command. Okay. Are you following? Okay, good. Back. I should remember your names. Sorry about that. G, if you want to pair up with her or with Miro to follow the lesson, okay. This is going to take an awful lot of time in my computer for some reason. So in the meantime, if you have any questions, just let me know. I guess the problem with my computer, this. Yeah.
I did all of that already, but it created like all of these budgets for me,
Oh, nice.
and I'm not really sure like how to untie. I think I created so New Org was like the name of my API key that I got.
Oh,
Yeah, and I need to like marry them.
maybe you go here on three dots, settings, advance it up there. This is going to delete this project, right? And at the bottom, wait, go for general maybe. Go to the bottom. Yeah, delete. So then you can clean up. Yeah, just need you copy this and that. Delete all of those and then you can create.
Okay.
This is for deploying your project, right?
Yeah.
Yeah, you don't need to deploy for today. It's just the local version.
Oh, okay, gotcha. Gotcha.
Do you have it running already on your computer?
So our this is just the exercise because like we already have the landing page for this. So for the exercise, I want to.
You can start from scratch for this, don't worry.
Okay.
So you pick a folder on your computer, any folder that you have, open a terminal there.
I have like this thing installed.
Ah, you have it already. Did you do every of the steps already?
Yeah, I did.
Oh, that's good.
Yeah. I'll
Okay,
just keep up then.
that's good. That's good. No worries. Yeah, mine is frozen yet. Yeah, it's installing. My installation froze, so I restarted. Did it work for you normally? Yeah, just that my computer is crazy. Oh, good for you? Okay, good, good.
I want to use the Grok API key instead of Open API. Does it have some text image?
Yeah, I don't know about image generation for Grok. Maybe you're going to need the OpenAI for that.
Oh,
Yeah, I need to check that, but it's possible. Okay. Well, people, for all of you that used Grok yesterday, it seems that Grok has the vision enabled, but they don't have the image generation. Okay, so we might need to switch back to OpenAI today. Yeah, no image generation. They have chat, they have audio, they have models, but they don't have image yet. Okay. Yeah, this can do multimodality. This can do vision, but it cannot generate images. It's not going to generate images for you. Okay, yeah. So you can use for this exercise. Don't know if it's going to work with the SDK. Maybe let me check that. Versal AI SDK providers. Yeah, no. The Versal AI SDK doesn't have image input for Grok yet. Yeah, not that I know of. But OpenAI is going to cost you like $2, $3 maximum. Sometimes less than $1 for generate those images. So you can put your credit card, it's going to charge like $1, $2 credits. It's not going to be heavy at all. I hope. Let's see how it goes. But you can, it's prepaid. So you put the credit there, like you put $2. If you need more, they're going to you're going to get an error. You need to top it more. Like a car, it runs on full fuel, and if you run out, it doesn't charge you anymore, like this. Okay, so finally my computer behaved. I have the files here. You can check. So this is the initial configuration. Remember, when we start this npm run dev, I have that very simple initial page in my local host. It doesn't have any functionality, any AI stuff at all. It's just a starting point, a placeholder. It's compiling, I guess. It compiled. It's just this placeholder with the Next.js starter, okay? This would be your output after you complete the step number 2, okay? If you, actually step number 1, if you run the server, you're going to see this page here. A brand new. Yeah, brand new. Okay, I'm going to stop here. I was just demonstrating. So you should have something very similar. And I'm going to install those 2 packages. I'm going to install the AI from Vercel and the AI SDK for OpenAI, because they have adapters for many providers, for Azure, for OpenAI, from Grok, for many others. So this is going to create the connections, the libraries that you're going to use inside our project, configured already for OpenAI, for the APIs of OpenAI. Okay, wait. Okay. This is going to install this and the OpenAI adapter in our project. This is another step that might take a while. Just to remind, this is not the only way to create a AI chatbot with OpenAI. Yesterday we created without the SDK. Remember, we call OpenAI API directly with the OpenAI package. So the SDK is only going to make it easier for us to call some functions here. Okay. That's an awful lot of time. For you, it's taking minutes too, or it's very quick to install? When you do this line, is it installing quickly? Yeah, maybe it's my computer. Okay, finally. Now we are going to start changing some files in the repository. We are going to first create a .env.local. It's going to be an environment for Vercel, choose only this local computer, with the OpenAI API key that you get from OpenAI, from the platform, not from ChatGPT, from the platform. Okay, we did that yesterday. And then replace that with your OpenAI key. I have it already in my system. Okay, yesterday we used it. If you don't have it, let me show the page again. Platform, OpenAI, login. Wait. Are you kidding me? That's crazy. Yeah, I got it up for you, okay? I fixed it OpenAI. So they keep on falling. I have to reset the servers all the time, okay? But now that I fixed it OpenAI, I should stop joking with this. Come on. That's not fair. Oops. Well, that's bad. My whole lesson depends on that. Oh, holy cow. The API might be working. API ChatGPT is and SOAR is down. That's not good. ChatGPT major outage. Labs. Okay, the playground is good. We might be able to access the playground. Okay. Oh, that's. Sorry. Yeah, maybe some backbone info going now. Well, let's keep on coding. Let's keep on coding. You remember that OpenAI key? If you pick from your .env file from yesterday, should be the same. Just copy the .env for the next project. Or if you have it on your machine, if you have the environment variable set on your machine already, it should be good. And we are going to start editing this file. The API chat route.ts editing. No, we are going to create this file actually. But instead of using the same code that we did yesterday, that would return the result object, we are going to return the string text object that is coming from the AI SDK. Okay. Let me run the core example just to see if it's working here. Yeah, it seems that the API is down, indeed. But okay, instead of doing the blocking page, instead of doing all of the wait time for, wait, is in the Chrome, all of the wait time for the answer to come, it may take 2, 3, 5 seconds of the blocking UI. We're going to use this streaming UI. It's not that hard to develop that yourself. Okay, it might be 2, 3 hours, 4 hours maybe, or maybe even less if you already did that in the past. It's just that there are so many things for you to take in account. For example, when you are streaming UI, user can I guess they state out here somewhere. A user can close a tab, and then you don't want to keep on streaming. A user can click on generate twice, so you want to finalize the first stream and then do the second. A user might get lost in the middle, lose the connection, and then you need to retrieve all of the previous package when going forward. So there are all of those edge situations that you need to develop by yourself that would take a lot of time. When you do it like this, it's for free, okay? You don't need to pay Versa or anything. When you do it like that, you just inherit this object string text from AI, And then you can return a streamable text response from this model, from GPT-4 or whatever. Yes, this is the power of that SDK. Okay, so let me create this file, API chat route.ts. I'm going to open this on Cursor. Yeah, time it out. Oh boy. Worst case scenario, we do a bigger break today, whatever. And then we document this, how a lesson was broken because of OpenAI. So I'm going to open that on Cursor. Who has installed Cursor already? Raise your hand. Nope. Don't like the idea? It's not mandatory. Cursor good. Yes. Because today I'm going to use a bit of it. For example, chatting with it. Yesterday we used this chat with one single file, remember? Today I'm going to chat with it using the whole code base. For example, I can ask questions about my whole code base, asking things like this: how to implement a multi-model AI chatbot here. And then instead of doing enter, we can do control enter or command enter. That is going to append all of the code base that I have for the AI to answer right now. Look how cool it is. It can compute the search queries of what we are looking inside the repository. It can search the files that are needed, and then it can pick the whole context that it needs to suggest the code. And look what I have. I have basically the code that I want from the lesson, okay? Of course, right now, if it's your first time coding this, you might be a little lost and all. But eventually, like 1 month from now, 2 months from now, 2 weeks from now, this can be your teacher. We have projects inside my studio that will be an agent being the teacher. This kind of chatbot, it still hallucinates, yes, I'm solving that, trying to solve that. But this could teach you people. Not because I'm lazy, it's just because I'm just one person. I can only help that much. And this can help you 24/7 in any language, okay? So we are going to use Cursor a lot today as a sidekick, okay, to help us gaining extra information about what we want to do. But let's follow those steps. I'm going to create a new file here inside the folder API chat route.ts. It needs to be exactly this folder structure, okay, people? Otherwise, it's not going to work, because later we're going to route this call for the API exactly like this. Do you remember why we cannot put this inside the page itself? For example, we could put this code inside the page.tsx instead of the route, right? What would be the problem? Who remembers? It would expose my API key for the end user. So this is why we need to bundle it in a way that the route is handling the backend, but the page is rendered there in the front end client side. I can pre-render the page server-sided with server-side rendering, then just fill with that call. Yeah, like we saw yesterday, this is how all handled by the framework. So you don't need necessarily to know how to code these things. If you are a very senior person, you know that you look like a very senior person, you look like a very senior person, maybe you know how to do this kind of things, but maybe for the newcomers, they don't. Okay. Are you very senior in coding front end? Are you? Very senior in coding front end?
Not very senior.
Okay. There are some seniors here. I've spotted some. So with this kind of framework, you don't need to be a senior front-end developer to do this kind of security standard and all. These people, for an early startup, for an MVP and all, can unlock so much value for you. Because instead of spending months and months studying all of those security practices before you do your first project right, and then you lose the time for your project and all, you can start with a very good boilerplate code, with a good base that has all of those architectures suggested for you. Then you can test if you have product market fit. Then you can test if your clients want to buy what you have to sell now. And then, of course, then you hire someone, an architect or a CTO, something like this, right? But you don't need necessarily to do that before. You can deliver something to the market, have some revenue, a couple $100,000, $1 million, $2 million, right? Just kidding, $10,000, let's say, of revenue, and then you know that this is a startup. Then you know that this is a project. Then you can start investing more in technology, right? So this is why I suggest this framework, these architectures. And here we're going to have this code to process this call for us in the backend. This is going to hide your API key. There are so many applications out there that expose the API key. You can go farming for it using ChatGPT for free. Okay, yeah. Quick pause for changing the clip there. Now we are allowed to curse the government while we're not recording. Just kidding, we don't want to curse the government, right? Recording again, good. No one said anything about the government, right? So this is, yeah, try to joke just to get your attention. I know that I'm not a good comedian, right? Our attention span right now is very short. So this is going to handle the connection from your application to OpenAI servers by calling the string text function from the AI SDK. Okay, let's see what it can do in the page now. Let me replace this whole page.tsx that I have there with this code. I'm going to have this chat component, which is using the use chat from the AI SDK. The AI React version we have using Next.js that uses React. And this use chat hook is going to handle all the messages, all the input. It's going to handle the input change. It's going to handle the submit. And we just need to display these messages here. We have in the line 8, one div that is displaying this array of messages here in line 9, displaying the role that I have inside this message and the content of the message. We saw that in the API call yesterday that we have those two. And in line 16, a form to input something. And I don't even need to handle the input, the message like we did yesterday, because we are going to handle that with the handle submit that we imported from the use chat. So we are reusing a lot of code. We just need to specify the positions, the triggering, the connections and all, but everything is going to be handled for us here. Okay. Let's test this before moving forward. Okay. Actually, before, I mentioned that, but I forgot to do this. At any point, if you have questions on this lesson, you can even ask the chat here. If you want to experiment with that, it's going to be very welcome. And you can ask things like this. What is this use chat doing? And then you can do a control code base that is going to read your whole code base and is going to explain what is this use chat. Control or command enter. And then this is going to use something called RAG, Retrieval Augmented Generation, that is going to carry inside your files, could be PDFs, could be code, could be text files, whatever. It's going to search there what is more relevant. It's going to bring only this part of the code base as an answer, and it's going to append that in the question, in the prompt for generating the answer. Maybe Cloud is down too. What? Yeah, this is good. Well, whatever. Let me start the server with that command, npm run dev. Let me see if the APIs have returned. Okay. Still down. We are so lucky. But they have identified the issue. Okay. Well, I'm going to show the interface then. It's not going to do anything. I'm going to give this error. But you're going to see the structure, actually, at least. So here is the structure. This is the div in the top displaying the messages. I don't have any messages yet. And I can input something like say something here. Hello. Then it displays here, okay? The API might not answer, the API is down, but this would be the interface, okay? Who is here with me? Good, yeah. Anyone with troubles? No, I am in troubles. The API is not answering, but let's keep on going. I replaced everything. Yeah. Sorry about that. Step 8 we didn't do yet, because at step 7 we were supposed to have a chat application, just like we did yesterday, but in less steps. npm run dev, yeah. But unfortunately, it's not working. Do you need help there? The API is off, right? Okay. Now let's do step 8, because then we are going to have some file input, some functionalities for us to upload a file inside that form. Okay. So we are going to import the use state and use ref from React. Step number 8, okay, people? And we are going to put there, together with the other imports, line 2, or you can create a new line, it doesn't matter. And inside the chat component, we are going to create those 2 lines. After you use a chat hook or anywhere before the return statement, we're going to create this use state hook for setting the files and files, just like we did messages yesterday. And this file input reference that is going to reference where the file input is in the page. Okay. It's going to be important later for us to display the image. No. Just like this. Yeah. The UI is working, cannot error, but the API is not working. I have my hopes high that they're going to fix that before the end of the lesson. So maybe if you take like a 20 minutes break and all, we're going to be able to play with it.
How much is like a typical prompt? Like I've seen it's like not even like a cent.
Less than a cent. It is. We spoke about that yesterday with this pricing page.
Is that page going to be available?
Yeah, usually the static page. So for example, for 1K tokens, that would be like a page of a book. It would be 0.0025 cents with GPT-4o. With GPT-4o mini, the one that I recommend, it's like 0.0000. Okay. It's just that when you have thousands of users, this pile up very quickly. Okay. So this is something you should consider at some point. If you're not running your own models, if you're deferring the model calls for OpenAI, you should make more money per chat than you need to pay for OpenAI. Much more. Otherwise, you're just a reseller for OpenAI. No wonder why they are so rich, right? They have thousands of resellers. Yeah. For image generation, that I hope that we're going to test today, it might cost a little more, okay? For example, with DALL-E 2, with the lesser resolution image, we have 1.6 cents per image, okay? Which is almost the same price as the high resolution. So it doesn't make sense too much to generate image with low resolutions. With DALL-E 3, with the HD version, you might be charged 12 cents per image, okay? So if you generate like 100 image, that's already $12. So that can be something more costly, okay? Be mindful of that. It's good that the API is down, we cannot pay them, but be mindful of that when calling the API. Okay. So right now I have this version, it's displaying my messages. Everything that I send is going to be appearing here, but we're not going to have messages from the AI being appended, okay? Sorry about that. Now let's do the file input part. I want to input an image, and I want the AI to answer for that image that I have put. I'm going to create this div inside the message content to upload some files. This div here. Step number 9. I'm going to find this message content here, and inside, just after the message content, or inside, it doesn't matter that much. If I have these attachments, those images, they call it experimental because the version is yet experimental, but if I have attachment, if the content type starts with an image, I'm going to display those images there under the content. So imagine if I upload an image of a cat, here under this message, I'm going to have that cat uploaded, displayed here. Okay? It's nothing about AI yet, it's just about the interface. Okay? Pay attention. You need to put this code block just below the message content. In line 15, you put that div out there for displaying the images if you have any. Then I'm going to modify the form element. Right now, a form element just have one input for text. The single input here in line 37, that is just for text. Now I'm going to modify it so that I can put a file like this and a text. Let me copy those two. I'm going to replace the whole form with the new form with this handle submit function that can attach these files and those two inputs. One input here for the file and the second input for the text that we already had before. When you do this, your UI should look like that. You should have this button here, choose files, near top. Step 8, there are two places for you to insert. You would put this import in the beginning, together with the other imports. Yeah, in the above or below, it doesn't matter. And you should put those two lines of code for files, set files, and also the file input reference below this line 6 here. Let me add a space here just to be informed. Okay. Step 9, pay attention. You're going to put this whole div after the message, after this message.content here in line 16, 15, 16, depending on your code. And then you're going to modify the whole form. This form here, you replace everything with this form here. Okay. And we do have the whole code here just for you to guide yourself to. Okay. Most case scenario, if you got lost, you can just copy this whole code here and paste there. It's going to work. Okay. Yeah, just after closing the div, actually. Did it wrong. Doesn't make that much difference. Just to avoid errors, you can pick the line 11, the step 11 actually, and copy the whole code and paste there. Should be the same. Yeah, just to explain the changes that I'm doing step by step. Yeah. You put one in the top here, and the other one here after the use chat. Yeah. Yeah. To avoid confusion, you can go for step 11, copy the whole thing and paste there. Then when you run the project, you should see a UI just like this one. Error. Okay, let me download a file like a Spider-Man meme.
Oh, is that what it means? So you can go to file?
Yeah.
It doesn't work without a file?
It works if the API is working, but
What if the API was working?
yeah. Save this image. Meme. And I'm going to choose this meme here in the desktop. And then I'm going to put it here. What this image is about. Yeah, error. Yeah, it should be. Yeah. Yeah, maybe we should put this there, like I told before, right? It would solve, right?
Well, you see messages on that. It's saying every time you render something in that, it needs to
Yeah.
So that key would have to move up to line 14.
Okay, need to be here, right? Maybe I just remove that diamond. Yeah. That makes much more sense because this diamond is not needed. Okay, good. Now let me choose files on this meme. And I can ask, what is this image about? And if I had an API working, I would have the answer, but we still have a problem. Okay. Good. Yep. 1 hour ago, still solving. Well, that's too bad. Yep.
How do we fix that key thing?
Sorry about that. Let me put the correct code there.
Oh, you just move everything up and down.
Let me do it right now. I'm too lazy to generate commit messages. It's being generated by AI, but the AI seems to be down.
Oh, well, you can call Sonic?
Yeah, it seems so. Oh, kosher.
No,
Yeah.
I mean, I use it cursor.
Try something there. Let's see if
What model are you using? What did you say? He's using a Claude working for you? Yeah, that's it.
maybe it's my computer then. Maybe I am the culprit here.
Let's see, double check. What is this?
Okay, clone, and then you're going to get the correct solution.
You already,
I don't know where that diamond came from because I don't have it in my code in the upper. Yeah, I don't have this diamond here. I just put it there. Well, doesn't matter. Now you have the correct code. It should work. And then your interface should look like that. And when the OpenAI APIs return, we can see the answer. And the answer is going to consider the content of the image and the prompt that you are passing, image and text. Okay. Grok, I guess Grok would have the vision. Is just that the provider version of the Verso SDK for Grok does not support the vision methods yet. Image input.
Oh, okay.
It's more a problem about the AI SDK than it is a problem about Grok. But if you implement manually, okay. Okay, recording here, good. What's here? Yeah, OpenAI is down. It's funny. Okay. Well, in the meantime, while we don't have the OpenAI APIs working, let me explain you a bit about multimodality. Yeah, we can go back to that exercise later, maybe 1 hour from now or something like this. Let me explain the computer vision models, how they work, how we can use that for image generation later. And we have one example here that is coming from Hugging Face. So it's not possible that Hugging Face is going to be offline too. I hope not. Okay. So we have this notebook, Google. Yeah, good. We have the next exercise ready because it's using Google and Google is working. Okay, good. So let's put that exercise aside for a while. Let's speak about computer vision. Okay. And then after this explanation, we do a break, and then we cross our fingers. Maybe we pray a year and all until the OpenAI fixes the thing, and we do that exercise. Okay. Who has ever seen those self-driving cars? There's like, have you entered one of those, took a ride, and with those, like Waymo in San Francisco? Do we have Waymo here in New York? I guess no, right? Is there any autonomous? Only California, right? And have you ever noticed that they have all of those cameras around? Measuring distance, measuring position of things with sensors is really, really tricky. You can do one measurement like a distance from here to there if you have a human operating now, but doing like a 3D map of things, it's really, really difficult. Detect people walking now. And even like ultra precise models with 4 or 5 years of research, they still fail in simple things like people walking down the street and all, because image is extremely variable, volatile. The data sources that you have for pictures, they change a lot. For you to detect if something is the moon or a yellow light, usually you need some sort of intelligence, some sort of context, because the pixels, they look like the same. Have you never been fooled with look at something? Oh, that is like a red ball there. Oh no, it's actually a red line or something. This happens a lot when dealing with image, because image alone is not enough for recognizing things. We need to have context around, right? For example, you are walking in the countryside, and like at the side of a dirt road, something, and you see a fence. There is a warning symbol, like a triangle with an exclamation mark, and a picture of a bull. Picture of a bull. A bull. Yeah. So I'm saying it badly, it seems. Yeah, we have one there in New York too. What you infer from it, you human? Imagine that scene. You see an exclamation mark inside a triangle and a bull in a fence, wooden fence, something like that. You infer?
Generalizing the model by general.
Yeah, but you are human. What would the humans think when we see this symbol? There is no much context, there is no words and all. What do you think? Caution, there are bulls around. In which side the bulls are? The side you are or in the other side? Probably in the other side. Like, don't cross, there are bulls, you might get hurt, cornered, I guess. So there's a word for that. This all is a context that we humans, we have because of social constructions, because we have seen that in movies, or you can do this deduction and all. Just by picking the image of that, it's very difficult to do this deduction. Like an image of a person, you need to deduct if that person is going to jump ahead of the car or not. If the person is walking that direction or the other, if it's looking at a phone, if it's carrying an umbrella. There are a lot of information relationships that are not evident there in the image itself that you captured. It could be a lot of things. The meaning of that picture could change a lot depending on the context, what happened before, what's going to happen after, and all. So there is this whole field of computer vision that studies exactly that, and it started way before text generation, like detecting images in the space, detecting meteors, detecting dark matter, black holes, and all of this kind of stuff. You usually have some raw data coming from satellites, coming from telescopes and all, and you don't have all the information there. You need to deduct it from this data source to give some information. The same thing like medical exams, like you take an X-ray, a body scan, and then you need to detect if this is a tumor or not, if this has some inflammatory disease or not. This is some sort of technique that can go from image to text or image to data point, Boolean, whatever, am I dying or not? This kind of model, we have seen that way before text generation. In fact, the capabilities of computer vision model have exceeded the capabilities of humans way before LLMs. For example, night vision. The ability of humans to see in night was surpassed by computer vision models 2 decades ago, more if I'm counting correctly. So this is one of the researches of AI that was there for a while. A lot of people made a lot of money on this, even before the current AI boom or any other AI booms. And right now, this is coming back into rotation, because when you pair up computer vision and text generation models, trying to search for AGI, for higher intelligence models, we're going to see some interesting effects. Okay, so computer vision in overall works by training the models with large data sets of labeled images or structured image and all, and it would do machine learning algorithms like deep learning networks and all to try and pair that sequence of pixels that you're receiving with that information that was labeled. Okay? Have you ever used OCR detector, like take a picture of a document and get text out of it, reading documents and all? Usually you need to do that when you're opening a bank account and all. You take a picture and then it can retrieve the information from a document. The characters are not exactly the same for the computer if they match pixel by pixel. But just because they have those shapes, then the AI can be trained to recognize that feature. When we are doing an inference over this model, we are going to pass a bunch of bytes. The computer doesn't know that it is an image. It's going to pass just a bunch of bytes, and then this model is going to make predictions of a new unseen data or extrapolate on that data. Just like when we prompt a GPT, it's going to output text. When we prompt a computer vision model, it's going to output some data, maybe drawing boxes, maybe colors, locations, or even text. Okay? And we have many of those tests, like image classification. I pass an image, and the model would be trained to recognize what is in the image, to categorize that image. Segmentation, that would not only categorize what is in the image, but also specify where those objects start and end inside that image. If there is a cat here and then 2 dogs there, you would have that segmentation. Same way that you do for image, you can do for video. Okay. Have you ever seen these filters, automated filters? Like you try to upload a picture, a selfie of you or your friends, and just because someone was with the thumbs up, then was like filtered out because it has inappropriate content. Or for example, if we're taking a picture of a pineapple with pizza with pineapple, right, G? That would be filtered out. Italian here. We have this kind of models. Not always you have a human moderating everything. Green, red, red, green, 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 red, green, red. So this kind of human moderation is not that effective or not that instant as a classification model. So when you upload images and videos, for example, YouTube does that all the time to check content, to check for copyright and all of this. There is no direct human involved when you upload something. They might review it later, but it is done by a machine learning algorithm. Object detection, that would be similar to classification, segmentation actually, but would draw the bounding boxes around those detected objects. This happens either for image or for video too. We're going to see one example of that. We have the zero-shot versions of these that it would give a classes or objects for it to detect, and it would find where in the image you have that with the most of the least probability. For example, instead of detecting every single object in an image, for example, object detection, you have a camera pointing to the street, and you are going to detect every object, the grass, a squirrel that passes, or the tarmac, or the trees and all. You can specify what you want to get out of it. And sometimes you don't even need to give examples. You're going to see some models that just by the textual description of it, like cars, like trucks, like motorcycles, this would be enough for the model to detect, classify, and segment only the things that you are passing, only the classes that you are passing. So it would ignore everything else. For example, if you are doing some traffic measurement, how many cars are passing through this bridge per day? You don't need to count any other things like animals or whatever, people. You just want to count cars. Okay, so you would do this zero-shot classification, detection, or segmentation. One example, because I'm talking and talking and talking, let me give one example of a computer model that is one of the state of the art nowadays, and it is open source. Is that okay? And it is open source. That is SAM, segment anything, specifically segment anything version 2. Because let me show one example. Okay. Because you can pass video or even image to it, and without computing, without training, without explaining the model for anything else other than a click on a specific place or a bounding box, the model can understand what is going on with this sort of contextual information. For example, here in this GIF, we click in the ball. There are a lot of white regions in the sock of that person out there, but the model knows that a ball is round and the footwear there it's contained in that bounding box, and it knows where one object starts and the other ends by some sort of contextual understanding of what are objects. Not every object in the world, but most of the objects where the model was trained on. So let me speak about this GIF later. So for example, if you click in an object in an image, like this boy there with this shirt, and you remove like the leg, just click on the leg, the model is going to somehow, this still amazes me, somehow is going to detect that it needs to remove all the legs, all the hands, the head, the neck, and all, and it's going to draw a perfect bounding box exactly in the shirt. And even is going to track that behind occlusion. People, this thing 5 years ago even like 2 years ago, would be mind-blowing, like, hey, how you did that? Take $10 million right now. And it's here, it's open, we can use. I'm going to show one example of that. This is computer vision. Yeah, just click and... No, actually, it was training on shirts, and it can understand what is the shape of shirts, and then it knows where to draw those bounding boxes. Okay, and this is great for video. This is the difference from SAM to SAM2, because now when you are tracking images of objects through a video, we can save this map of information about those objects, and using the future generations in the futures masks, draw bounding boxes over those objects. Okay, this is the new part from SAM2. This is computer vision. Okay, that is, oh, this one is great too. For example, if you pick a person playing ping pong, select the T-shirt and then unselect the head, someone would still pick the head, and some problems in the bounding boxes. Here we have, in SAM2, we have this perfect bounding box exactly around the T-shirt. Okay. So you can track, perfectly track, detect, segment objects. Okay. Can search for objects inside images now. Thank you. Questions about this model? Like traffic, it's a very obvious one. Military, this is a very obvious one too. Yeah, logistics, like imagine a warehouse full of boxes now, where this box is now, you don't need to have all of those sensors. Climate, detecting like cloud formations, rain, all of that. Like aerospace tracking, anything that you would require sensors to get, now you can do just with video. Okay. Have you ever been to China? It's another example. Let's skip that. Yeah.
Yeah.
Okay, so there are many uses for that, you know. The good, the bad, and the ugly. Okay. Wait, what? That's being recorded. Okay. Well, I did not speak against that. Okay, it's just that they have this technology and they use. Did I say that it's bad? Did I imply that it's bad? No, right? So, for us to try it out, I know this is a very heavy model for us to run in our own devices. I suggest that we do this collab, this Google Colab. Okay, that is a notebook that runs inside Google, and they give you a very big machine. For example, here I have a T4 that has 15 gigabytes of VRAM. Okay. I could run a lot of things on it. So it's just a notebook like the one that I presented in the first lesson that would guide us to use this segment anything. Okay, so if I run this first box here, this first code block, we're going to see what kind of GPU we are having. So ideally, we need to have, ideally we have access to hardware accelerator. In the free plan, you only have some minutes of it. So if you use it that too much, you might need to buy some credits or use another account. Okay, but here we have 15 gigabytes of VRAM. Should be good enough for running this model for a while. Okay. And then we're going to do some setup. We're going to clone this repository, segment anything to. It is an open repository, okay, people? And the license is under Apache, so it's great. Like we can do any kind of modification, commercial use on top of that. Okay, so it is a great model with great powers running into an Apache license that we can using anything that we want for our projects too. If we want to do like computer vision and all, this is available for us to download and use. And this notebook is going to show around some tasks. For example, decomposing the image of this dog. Where is the head? Where is the tongue? Where is the nose? Where is the backpack and all? The model is going to be able to process this and create those masks automatically. Okay, we can detect objects. For example, in this table, we can draw bounding box around those objects here and detect where they start, where they end, and the model would do something like this. And would detect this is a napkin, this is a salt, this is pepper, this is a dog, something like that. Okay. Let me see if the OpenAI is still off. Yes, it's still out. Okay, well, that's crazy. Yeah, but we can try this computer vision here. That would explain how the OpenAI can extract information from that image. And don't know if we're going to have enough time. If you want to do this collab here at home, you just download the GitHub repository here. This line is still going. It's going to install everything you need Python to run, and then you can run the model later. And the interesting part of this kind of models, of this omni capabilities of models, is that there is a research going on for a while now that the joint information, what we have right now, for example, of AIs that are training in world scope 1, just the textual representation, and maybe world scope 2, that would be the written word, would not be enough to do natural language processing tasks. Okay, we would have those diminishing returns and all. This was proposed like 5 years ago, and it is quite accurate. So when you join information about the world of sights and sounds inside AIs, like computer vision is doing, we enhance the ability of natural language processing itself just by having pictures of things. And this is crazy. We're going to see that. At some point, we might even join the embodiment part of it, of actions like robotics, sensors, and all. And in the fifth part, maybe some social world. For example, this bull word being written in the side of a fence in a large field, for example. This is a classic example that by a social construct, we could infer that there is a dangerous creature there, and the word is written in the opposite side of the fence where the creature lives. This is not something that is there explicit in the image. The AI would need to retrieve that from somewhere, from some social construct and all. And this is why we have these multimodal models, more performatic, like GPT-4o and Llama 3.2, that are like the same version of models, but with image capabilities, vision capabilities. They had an increase of performance in text. And no one, like, we did not train on that on text, how it comes. Because when you are doing, let me pick this article here, not this one, this. When you are doing perception data sets that would be multimodal with textual data like internet data sets and images at the same time, you end up creating more information, more, how do I say, a strong link between the information that we are passing and the essence of the object itself. For example, just with text, just word scope 2, I'm going to pick this water bottle, okay, and I'm going to hide it from you. And I'm going to start explaining it, like it is blue, it is round, it is a cylinder, has a cap on it, the bottom is dark green. I can start explaining with words. And you would have a good understanding of that water bottle, right? until you reach a plateau. And at some point, I'm going to be telling and telling, and then you don't acquire any new information from this water bottle. It's round, the circumference is this, the height is this, it is a little worn, it has some marks on it. I'm going to be explaining that water bottle for 2 hours. At some point, you don't have anything else to learn from it with text, right? But then I do this. Then I show this water bottle, and then you gain a whole new perception over this, and then I rotate it. So this is what is happening with most of the AI models that we have right now. We are throwing a lot of information in it with World Scope 2, just with data. But when we start exploring with World Scope 3, maybe World Scope 4, we don't even know World Scope 5, this could be a path to AGI. Or not, maybe this doesn't work. Well, it's research, we don't know yet, but we see increase on correlation when we go that path. And I'm going to skip the whole explanation. I'm going to use just this image to try and summarize what is happening. I have some text string, for example, 2 dogs running across a frosty field. And I have some embeddings for it. Here is represented in 2 dimensions, X and Y. But imagine that I have like 700 or 4,000 or a lot of dimensions for this, okay? X, Y, Z, A, B, C, and all of that, a lot of dimensions. And I would have the embeddings represented here. And somehow, when I embed this image, the content of this image, I'm going to have a vector, actually a tensor, that is almost close, where the direction is very, the distance is very close, one dot from the other. This is what computer vision is doing. And if I try 2 different images, like this whale fin atop of the water, and this string, an elephant in the Serengeti, those are very further away than those 2 that are very close. So whenever we're going to see image generation, whenever we want to generate an image of 2 dogs running across a frosty field, we would be closer to this. And whenever we ask, what image is this? Then we would have this string coming up, probably, because the model has learned to do this, okay? There is a text encoder, transformer that creates this encoding, and there is a visual transformer that creates those same encodings, okay? And then the mountain landscape text would have almost the same encoding as the picture of a mountain landscape. Numerical data, those embeddings, okay? This is done by doing some contrastive pre-training in learning, by pairing up those strings and images together and trying to learn inside the neural network that those images correlate to each other. Like in the diagonal, I would have a number as close as 1 as possible. Yeah, the 2 dogs running across a frosty field. If I pick the dot product of this tensor, of this encoder, with the tensor that comes from this image encoder for this image, I would have almost 1. And if I pick this string, whale fin appearing above the surface of the ocean, and if I do the dot product or the cosine similarity of this embedding with the tensor resulted on this embedding, with this first image, it would be close to 0. So ideally, the diagonal is going to be as close to 1 as possible, and everything around is going to be as close to 0 as possible. Okay? I have a notebook to demonstrate that too. Maybe we should do a break and see if the OpenAI APIs returns. Okay, but okay. Here would be the explanation of the clip. For example, if I ask for this model, where is a zebra, where is an elephant, and where is water? It would calculate in that image that there are zebras here, there is an elephant here, and there is water here. Yeah, they printed it like a thermal image, but could be drawn bounding boxes too. This is semantical. I could even do like dangerous and not dangerous. It would paint the lion, not the elephant, something like this, okay? That's the ability of computer vision.
So Clip is a model that's already been encoded with all of those.
Yeah, the clip was released, let me see, I have this in January 5th of 2021. It's quite old, and it's being reused in later things. It sparked the whole stable diffusion movement of image generation. It's been there for a while. Let's do a 10 minutes break or so. We come back at 8:30 to wrap up the image generation part, and we see if the OpenAI API comes back. Okay, good. Short break. Okay, people, so don't worry. OpenAI people didn't get vacations yet. They are still working on the fix. Okay, they didn't go home. They are still working. That was the update that we had. Let's speak about image generation then. I'm going to skip the tool setup here. It's going to be quite complex for the time that we have. Let's get to the introduction. That is basically generating pixels, bytes in the form of pixels that form a coherent image that humans can perceive that was indeed the information that we wanted to generate. This is going to use the powers from models like this. Wait. From models like this that are trained to encode information of text and image at the same time with a technique called stable diffusion. Different from those other image generation algorithms that we had in the past that would go for the image directly, would compute the pixels of the image. We have some new generation capabilities with the transformers architecture, the same architectures as the GPTs. Remember, generative pre-trained transformers. But here we have visual transformers, clip, in place to do a technique called stable diffusion. That's not going to generate images in one go. The first model was from Stability AI, yes, but I'm going to show all the models that would do the same thing. That would come from a prompt, like a textual prompt like this, a scene of a gigantic ancient tortoise with a fantasy city built on its back, blah, 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 and then it generated that image. There was no human involved in that generation. Okay? And it's very different from those other models that I have mentioned here, because generation can happen in seconds. Okay, if you go for GANs, from VICE, for convolutional neural networks, recurrent neural networks, and all, you take minutes, if not hours, to do image generation. When you use transformer-based models, the same leap that we had with GPTs, we can do the processing in parallel. For example, using GPUs. We have been using GPU for parallel processing for a while now, for rendering things, for games, for hashing operations. So GPUs are great for doing that. They can compute a lot of things in parallel, which gives unparalleled performance, no pun intended, when doing this processing for doing this generation. So for example, we have DALL-E that uses stable diffusion, but also with the language capabilities of the GPTs, stable diffusion itself from Stability AI, or all the other derivations from stable diffusion, Imagen from Google, Bing that uses ChatGPT with the designer, Midjourney. This one got very, very famous. Most of you probably heard about Midjourney in the past, right? Yeah. There are many others like Dream Studio, Stable Diffusion, Adobe, Crayon, Pixar, Image FX, and all. Let me pick one of those. The Bing Image Creator, for example. This is some like freemium application from Microsoft. This is in DALL-E in the back that I can create anything, literally anything based on text based on words that is going to search in the definition of the latent space. Let me go here for that image again. The model is going to search in the definition of latent space for this string that you're going to put, and is going to generate some image similar to that. Okay. What do you want to generate today? Give me some suggestions. Okay. I have too many tabs open. Yeah, here.
How the model got trained with all these, like they just push images and they tag them manually, or how they got correlated? These are two dogs. How were the first one contacted? The model understood that this is at dog.
Yeah, the data starts always prepared. Wait. Let me find a better place with this image. 1 second. Yeah. Speaking about computer vision yet. So the data is going to be prepared, tagged, correlated, is what I'm trying to say, with the captions. You have trillions of data sets like this, maybe billions actually, of data points like this, with images and caption. And you see the captions are not that perfect. Right, soaring by Peter, Edith. This is not a very good description of that image. This is not a very good description of this image. Far Cry 4, blah, blah, blah. It's not a very good description of that picture. Yeah, this is probably image data is scraped from online forums, from gaming forums, from Reddit, from social media. It's just a random collection of images here, okay? Would have that paired. And then at some point, the model would learn with pre-training, with this contrastive learning in pre-training, how to maximize the weights, how to calculate the weights to maximize the dot product or the cosine similarity of this diagonal to 1 and minimize what is around, whatever is around. So that whenever I say this is specific string to dogs running across a frosty field, any picture that look like this, in this direction and the other direction, the dogs coming up, down, with more snow, with less snow, with hills, without hills, with persons, without persons, whatever, the more variety of information that I have, the better, because the model is eventually going to correlate those two. Okay, not perfectly, but it's going to get close. And you see, the training happens with the content. It doesn't happen too much with the position. Okay? I'm not training to detect if the dogs are in the beginning, in the middle, or in the end, one ahead, the other, or below and now. So image generation and detection is very good for detecting things. But if you try to generate something like an apple above the hand, and the hand is below a tree, it might not get that positioning that correct because of the learning. The learning, it's only about the subject itself, not much of the position. Maybe the color and all, but certainly not the position. This is why when you generate like hands, sometimes you have 6 fingers, 4 fingers and all, because we are not training the AIs to count things, to anatomically represent things in the correct proportion and all. So this is very tricky, very tricky. So let's try something here. Have some ideas of what we want to generate? Tell me. Rainy day. It's going to be like a normal day. Not yet, not yet. This is just yeah, I generate a lot of pizza pictures. Let's see. Okay, that was good. Yeah. Yeah, that's very realistic. perfect, this picture of New York. That's perfect, right? But why this car is going the wrong direction? Because the AI was not trained to get directions of things. It's trained to get shapes and outlines and all, you know.
And the zebra line is
Yeah.
Nobody can shoot that bad. Yeah, it's just AI.
And of course, there are a lot of biases. For example, this image that I generated a while ago was a picture of some Brazilians in a party. And this is the bias of the Brazilians. For example, I'm going to try, may I try some Italians having fun?
yeah. The same one, but Brazilian.
Probably is going to have some pizza on it. You know why, right? Because every time we have an image tagged with Italian, we happen to learn that that is pizza. Okay.
Where is it? In the top line.
You have fun with
Why is that? Because the AI is racist, the AI is biased and all. Because of the training. It is statistics. Okay? And unfortunately, we have some bad statistics biases out there. For example, generate a picture of a nurse probably is going to be women because most of the pictures that we have with nurses are depicted as women in the image that we have in the internet and all. Does it mean that a nurse should be always women and all? When we generate those images for advertisement and all, it is very difficult to deal with that. Okay, now you know why. It's not because of big corporates bad and all of that. Not saying that they are good too. But now that you understood the basics, what was it? 1 hour, less than 1 hour on that. Now that you understood the basics of it, you know that the pre-training effect of it, because of how the labeling works, is causing this kind of biases. Okay. And a fun fact there, I would have more time to explore this, but the process is not done entirely at once. What we have actually, let me see if I find this GIF here. What we have actually, this is why it's called stable diffusion. What we have actually is an image that starts completely pixelated, noised, completely random, and we don't go directly to the final image. We go removing noise, randomness, line by step by step, one by one, until we paint the final picture. This is the process of stable diffusion, because the denoising process can be learned. We can have how to learn how to generate images. We don't know, but how to learn how to clean images. We can learn. We pick data set of images, like this image that is a clear picture. We know that it's a pyramid. This image that we know that are books and all, and we add some noise to it, some randomness, some splashes, some pixels to it, and we save this into a database. Okay, this is called forward diffusion. We save a little pixelated version of this, a slightly more pixelated version of this, a totally pixelated version of this. We save all of these images in the model, and we would have the output, the label, and the amount of noise. We would learn this with a UNet, with a kind of neural network, to predict this noise. So whenever I'm generating an image, I predict the amount of noise, I subtract this amount of noise, and then I have a slightly less noisy version of that image, step by step, until step 1, step 2, step 3, step 4, until I have the image generation out there. So we have at the same time, add this, blah, 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 blah. We have at the same time the denoising process that starts with the image and then go denoising it step by step, and the text information. Because I could start denoising the image. For example, I want to generate a cat. And I start denoising, I calculate the noise, and then what I'm generating is a dog. The denoising process is working. but the information process that I want to generate is not working. So I can use the clip together with the denoising process to converge. It is going to be a clear picture, and it's going to have a dog at the end. And everything that goes outside of this is going to be discarded. Okay? This is the shortest way that I know how to explain this box here, how to come from text to image with Stable Diffusion, or text and image to image. That's possible, okay? So it's using the computer vision and using that clever diffusion thing. Maybe in the future, we are going to have hardware capable enough to generate the image without diffusion, but so far, this is the only way that we can generate it properly with quality like this, okay? And we have like 5 minutes or so. Yes?
If you're given a model image of, we'll say like a person, and then having it like generate that person like doing different things, like how does that work?
In the Stable Diffusion?
The same process?
Yeah, no, here we have just text directly going for pictures. But for example, in this QR code that I have in this example here in this article, like I have this picture, and I pass a pirate ship, and then it would paint the pirate ship there. You know?
So now let's say I want to say, all right, like take the same pirate ship and put it in like a storm.
Yeah. So for example, we can do the masked regions, like only change the sky now. But for example, if we are going to change the whole pictures of the image, this is done by manipulating this thing called a latent space. Okay, where I have, yeah. Let me explain that. The actual generation, it is not computed in the pixels of the image itself. For example, a pixel of 512 by 512, 3 colors per pixel. Okay, so we would have all of this information in the image. Actually, the image generation doesn't happen here in the image itself. It happens in something called latent space that has just an information tensor with 4 by 64 by 64 that would guide what is inside the image. Okay, like some embedded representation of that image itself. So when you ask it to be a rainy ship, for example, a pirate ship in a rainy beach, it would start with this latent representation of that image. I would come from the image to latent representation instead of starting 100% random, and I would converge from this starting point. Okay? So instead of starting something 100% pixelated here, instead of starting with something 100% pixelated, I would start with something that resembles a ship, and then I would add the noise until I have the rainy ship or something like that. Okay. And here we are viewing the results at every step, but usually we don't do the result in every step. Usually we only do this image decoder at the end because it's useless to do it in the middle. So usually we start with a random image information and the embeddings of what I want to generate. And then at the end, I have this process information tensor. And then I use one model, that's the image decoder, the autoencoder decoder here, don't need to worry with that. That would paint the final image here of the ship or whatever. We don't need to do that at every step like we have here. Maybe this causes some confusion sometimes. But if we do it at every step, we can see this generation going pixel by pixel, like between the step 2 and 4. Look how the image gets painted. It doesn't move the actual pixels around. It just refine them until it has this relationship. And if I generate a new random initial vector, it might give a new random information here for that image. Okay. So I would suggest us to test this with DALL-E, if the API is working. Oops, not working. To generate images with DALL-E. Whoops, not working too. So we would be able to pass those parameters for the API, and then it would allow us to generate images with other images as input or with prompts as input, like I would do in this API endpoint here, okay? And I even explain how to generate, how to run those generative AI models in our own devices. Okay, I have this tool here. Let me show that for you. Stability matrix. But we are not going to have time to actually go through it. I can leave it as a homework for you. And while OpenAI is not working, that could be our only resort for generating images in this lesson. Let me show that software. Okay, guys, I can close this other one. What I'm going to show is a tool called Stability Matrix that is able to load packages for image generation. What's this too? And I'm going to load this package called Stable Diffusion Web UI. That is a Web UI tool. It is a graphic interface that we can use for running those Python scripts, for running those models that we can load from the Hugging Face. I just had an error. Well, whatever. And this Stable Diffusion Web UI is going to load the checkpoints that we download from the Hugging Face model. The DALL-E, for example, it's a closed model. We can download a Stable Diffusion from Stability Matrix, or Flux from Stability AI, or from all the from Stability AI. No, wait. Flux. No, Flux from Black Forest, actually. We have all of these models that they are like open source. We can download them and put in our own machine. Usually they require Python to run. For example, this is a Python code that I would be able to run that model. Or I have this application here that I'm going to show for you. Stable Diffusion Web UI, running with that tool that I mentioned. And for example, I can pick this Flux, or the normal. This is the normal Stable Diffusion from Stability AI, the original one. Stable Diffusion 1.5, prune, and blah, blah, blah. I can generate anything. Like, let me try this prompt again. Some Italians having fun. And even though I don't have OpenAI API working, I can use my own GPU, totally offline, totally private, to generate that image here. Okay, let's see if it's going to work. Under a minute. This is using my own GPU with this model that I have downloaded before. All the information how to download this now, it is in this section, setting up Stable Diffusion Web UI. It's not needed for future lessons. Is that I explain how to do the image generation here. And I would have an exercise for you to do a button to generate an image based on a prompt in a text input. You can use OpenAI normally. Okay, but if OpenAI is not working, maybe you want to resort to this to do the image generation. Okay. Hey, G, you are here. This is a very old model. So look, the quality of the generation is not good. The faces are like deformed and all, but it generated. If I can do like, yeah, I can do like pepperoni pizza. Maybe that's going to work better. Okay, and this is using my own device with this model to do the Stable Diffusion pipeline. You see how the image starts blurred and then goes gets refined step by step. And by the shape of it, it seems like it's going to become a good pizza. Yeah, it's going well. Now the only next step is how to print this pizza. Oh, come on, it doesn't look that bad. Yeah. 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 Give me a break. It was like 4 years ago, released it a while ago, so 3 years ago actually. So imagine what the recent models can do. Okay. Questions? We are above time already. Yes.
If let's say more than one person go to the thing and type the same exact prompt, would we all get the same exact output?
Yes, but only if they start with the same randomness. There is a seed that governs this. If you start with the same randomness with the deterministic process, yes, you're going to have the same image.
If you go to page or down, let's say experiment, like the whole class would type the same word, would it be the same output at the end?
Here we cannot pick the seed, but for example, in Stable Diffusion Web UI, we can. What it is? Here we can. There is this parameter seed that we can configure, and here we can log. And if we log the seed, we're going to do the same generation all the time. Unless I'm using some sort of samplers here that are ancestral samplers. I did not explain that today, but there is that in the documentation. That they add a little randomness step by step too. And then you would have some variations at the end image. But using normal samplers instead of ancestral samplers, you have a deterministic process. Okay.
Is it the same amount of effort on your GPU to develop pepperoni pizza compared to like a really complicated problem?
Yeah.
Because they're both like the
It's
same amount of parameters.
it's only going to change if I go above 75 tokens here. If I start typing a lot of things here and it goes above 75, then I'm going to have a little extra computation that would join 2, 3, 4, 5 batches of information in one representation. Okay, but it's minimal. Uh, it doesn't require so much. What is more resource intensive would be loading a model with a higher amount of parameters. For example, I have one here for realistic images. Sometimes I load this, it breaks my computer straight out. So these would be heavier, or generating more pixels with higher resolutions that would amount for a bigger latent space too, a bigger conversion. That would be more tricky. That would require more resources.
But you have models downloaded.
Yeah, I have them downloaded beforehand.
What's the average size?
A few gigabytes, up to like 500 gigabytes
500 gigabytes?
for the top ones. But for example, Flux image from Black Forest, Hugging Face. This one, I would have a model of the size of 23 gigabytes, for example, which is reasonable. It's not the smallest one, but it's reasonable. Yeah, well, that's not a good pizza. It has mold on it, maybe. Yeah. Okay, this wraps up for today, people. Tomorrow we start the decentralized part, blockchain part. We're going to have 3 invited sponsors to guide you on how to do the link between Web3 and AI. I'm going to be teaching to you. They're going to be streaming. These things are going to be working. Okay, and we are going to have the interaction between you here and the sponsors streaming with code lessons on how to deploy decentralized models, smart contracts, decentralized AI agents, and all. And in Friday, we have more talks until we prepare you for the final pitch at 8 p.m. or so in the Friday for you to pitch your projects, your ideas, actually, for the judges, for us to select the perks on the bootcamp. Okay? Probably I'm going to have perks for all of you. We have more perks than projects, but even though it's a great feedback and interaction with the judges, right? Yeah. More like I'm going to speak about that tomorrow. The objective is for you to show as much as possible. Since you asked, let me show this. Show as much as possible and tell as little as possible. Explain as much as possible of your project with visual demonstration of things that you have built, and avoid longer explanations. So if you build a deck, try to put images of like your AI generated landing page, your working version of the multimodal app or something like this, because that's going to be much more impactful than a slide showing the market research about your idea now, okay? Not saying that you shouldn't have, just that the more that you show with sources, with facts, with pictures, with the live demo, the better. Okay? I'm going to speak about that tomorrow. Good. Well, this is it. Thank you all for today's lesson. That was a good rainy day to warm us up before, but now that we dominated the AI part, we're ready for applying Web3 on it. Thank you, people.